Hey folks, we're here to talk about Boraginaceae today. This has always been one of my personal favorite families because of this really cool inflorescence type that they have. Notice that their inflorescence kind of looks like a scorpion tail. They have this spiral inflorescence, which we're going to talk about in a little bit. Here's a really well-known member of the family. It's called forget-me-nots. So hopefully you can remember that. Just kidding. You don't need to. It's not required. It happens to be the state flower of Alaska, and we have this as a weedy plant kind of all over town. I'm not going to tell you the genus name right now because it's actually a really good practice keying unknown, and I would love for you to go find it and key it out. I just told you the common name for it, so you'll kind of know when you get there, right? And you can find it flowering all over campus if you walk to, say, like right by the sign that's on the way up the library hill, kind of near the parking lot on the right-hand side of that turn you have to make to get up towards the library hill. Cool. You'll find it all other places in town, too. Anyway, what you can kind of see from this picture is that they've got actually more of an unfused calyx than Solanaceae, which, by the way, Boraginaceae and Solanaceae are very closely related families. They're both in this kind of larger group of families called the asterids. And a lot of members of the asterids, including both Solanaceae and Boraginaceae, have this floral formula. They're almost always actinomorphic, with some exceptions, for sure. 5, 5, 2. And then some other features, almost always a superior, always a superior ovary. 2 fused carpels. The petals are fused. Sometimes the sepals are fused, sometimes they're not. And then there's more fusion. It's adnation between the petals and the stamens, or in other words, epipetalous stamens. So this is the floral formula for both Boraginaceae and Solanaceae. To be super clear, go back to your Solanaceae notes and please apply this to the entire family. Cool. Let's move on here. Okay. This is another well-known member of the family that you might see as a weedy plant around town or growing in your yard or something. And you can more clearly see the free sepals here. There's 5 of them. They're just free from each other. And again, if you see this around town, please key it out. It keys out really well. They do have something really fancy going on. They've got their 5 sepals. You can see them right here. There's 1, 2, 3, blah, 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 4, 5 sepals, meaning these larger things are the petals. Makes sense so far. Well, the stamens are kind of in here, right? Those long things. But then we've got this sort of other structure. It's this thing right here. And then it also extends like this. It's this fancy, round, kind of crown-like structure that sits right in the middle of the flower. And it's derived from the andrecium and or the corolla. And mostly the corolla, I think, in most of the taxa of this family that have this structure. And you might have already guessed what it's called. We met this term in genus Narcissus, actually. This is called a corona, which technically just means crown. It's very just not the most pleasant term right now, so just know that some members of this family have a corona, and others members of this family do not have a corona. Some don't have a corona whatsoever. Here's another kind of cool diagram looking at just another member of the family, and what I like about this picture is this nice longitudinal section. You can very clearly see here that the stamens are fused to the petals right in there. Sometimes we do have flowers like this. You might recognize this as a salverform corolla shape, which I talked about in the Solanaceae video. And I think these pictures down here are the pollen grains. Look like scanning electron microscopy images of their pollen grains. Very cool. We don't really talk about that, but it is cool to talk about. There's whole studies on palynologies of species. Family palynology is the study of pollen grains. It's very cool. F is a very important image in this one. We need to talk in more detail about this gynoecium. Notice, that's a gynoecium. And it's very interesting looking. It's deeply four-lobed, so we'll talk about that in a sec. Let's talk about these inflorescences first. This is the most distinctive part of the family, just meaning when you see that, you right away you think Boraginaceae. Now, there are other members of other families that have this thing. Do you remember this type of inflorescence where the initial stalk terminates at the oldest flower, and then it branches below, and that's where the next oldest flowers are, and then the younger ones kind of branch below that, and so on and so forth. Sometimes this can happen many times. Okay, well, this is like that. That, what I just drew, was a cyme. And what happens in this particular type of cyme is that whole branching pattern that I just showed you, it happens, but it's entirely one-sided. So here's that oldest flower. The branch terminates at the oldest flower. Below it, it branches, and then there's your next flower. This time it's just one-sided. Then below that, it branches. Below that, again, it keeps getting younger and younger until you get this cool kind of scorpioid, helicoid, spiral cyme. So that's why they tend to call this, a helicoid cyme. I've also heard scorpioid, or I've heard other terms for this too. In fact, actually, there are slight differences between those types of cymes, but I'm not going to hold you to those. Just know it as any of those. Scorpioid cyme's fine too. Here's another look at that. This is some Phacelia, which is a genus we're going to talk about later, that I collected recently, and it's in my vase right now. Took a picture of it. Notice these helicoid cymes are sort of problematic because as they are growing, they're getting older. Those flowers, which are like in this one that's closest to us out of focus, this is like the open flower right there. Everything below it is older. These are all the older, like the oldest one would be down here. So as the helicoid cyme develops, it ends up looking like a raceme, right? Because you've got the oldest flowers at the bottom and then the youngest ones at the top. There's just slight differences here. It's just that the original flower the branch is actually terminating in that. And there's sort of no evidence of that or very little evidence of that once they get to this stage. They sort of just look like these curly racemes. Just know the difference. They're actually considered cymes. Just so you know. And here's a picture that I took actually just 2 days ago. I went to Gray Falls, the Gray Falls campground, and I went to the day use area. This is about an hour inland off of Highway 299. If you get a chance to go there, I highly, highly recommend it. You can kind of walk around and see tons of required taxa. There's a few trails that lead down to this river that you can kind of see in the background there, the Trinity River. Like I said, this is about an hour inland off of Highway 299. I believe it's 4 miles past the only rest area. That's just right after Willow Creek. I highly recommend going there. There's one of those cool members of the family. That's actually a non-native member called Amsinkia. Still very beautiful. Let's talk about that gynoecium now. We talked about the inflorescence. We got to talk about this gynoecium. Here's a really beautiful image that I found from the internet of their gynoecium, and what's happening here is this is the style right here, right? Or in this picture down here, oopsies. This is the style right here in that one, and this is the style in this one. Notice that the style is sort of attached right in the middle of these ovary lobes. So this is crazy, actually. This whole thing is the ovary, or like in this one, this is an entire ovary. And this one ovary is deeply four-lobed. And believe it or not, remember from the floral formula, it's actually 2 fused carpels. What? It looks like 4 unfused carpels. It looks like an apocarpous gynoecium of four carpels. Like, let's be real. That's exactly what it looks like. The reason why I know it's not that is because if these were 4 separate carpels, well then each one would have its own separate style, say like coming off like this. But instead we don't. We have a united style. There's one in the middle. And the fact that the ovary is kind of at the base of it, the style is attached at the base of the ovary. There's a fancy term for this type of style. It's called a Gynobasic style. Which makes sense when I write this word, Gynobasic style. Attachment. Like, that's how it's attached. Gynoecium, basic, it's attached at the base of those ovary lobes. So that word kind of makes sense. So what's going on here is that, like I said, it's 2 fused carpels. Well, this is one carpel, in theory, that's deeply lobed, and then this is the other carpel that's deeply lobed. And there's a total of 4 ovules per ovary, or in other words, 4 seeds per fruit. right? This whole thing is going to become a fruit. It is the ovary. But it's actually going to split into these four single-seeded units. See what I'm getting at? All right. Here's another look at what these can kind of look like. When they split into these 4 single-seeded units, in this family we call those nutlets. Love that word. It's like a nut, but smaller. You know, like pig and piglet. Piglet is a smaller pig. It's a nutlet. And they're just kind of smaller nuts. They're not technically nuts. In fact, what nutlets are merocarps. Remember that term, merocarp? It's actually a merocarp. Okay. So here's just a cool picture of a member of Boraginaceae. Sometimes they can have very, very tiny flowers, as you can see from this one that's to scale with salt grains. Those nutlets, at least, are to scale to salt grains. I don't think that flowers... Maybe it is, also. It must be. Actually, wow. Very, very... They definitely can have very, very small flowers. This is a picture of a single nutlet from a different species, just showing some diversity. Sometimes these dispersal units, these single-seeded dispersal units, have hooks. What do you think those hooks are for? Yes, they're for animal attachment. They're for attaching to, you know, animal's fur or your sock, something like that. Okay, so here's just another look for you to kind of have to study. And we have, like I said, this deeply four-lobed ovary developing into nutlets. And when we look at the entire thing, say all of them together, as it's developing, this is a schizocarp. That is the most correct answer for the question, what is the fruit type of Boraginaceae? With a catch, this is only the gynoecium of a good chunk of the members of the family. They either have a schizocarp with 4 merocarps, which are called nutlets in this family, as we talked about earlier, and as they say right here. But other members of the family just kind of have a more normal gynoecium, where it's just sort of like a lump. It's still 2 fused carpels, and usually, I mean, maybe they have like 2 separate styles. Here, this type of gynoecium would just dehisce and therefore develop into a capsule. So we've got some members of this family that produce capsules, others that produce these really exciting nutlets. Here's another look at a member of the family. These are very small things sometimes, other times they're quite large structures, plants. What we can really clearly see in this picture are these hairs. See all these hairs, like on this calyx, for example, or all over these nutlets? Well, we have a very kind of specific type of vestiture that's found in this family. Not all members of the family, but many members of the family have hispid hairs. Hispid hairs are ones that are kind of like this, where they're very stiff. You can kind of tell that from the picture, I think. They're stiff, but they're also small. They're annoying. They can definitely hurt you, not badly though. They're just like itchy and very annoying sometimes. But at the same time, they can cause rashes. Some people do struggle with the hispid hairs of Boraginaceae more than other people. Cool. Here's another look. This is a really beautiful native member of California that I also saw at Gray Falls the other day. This is called Cynoglossum grande. And this one very clearly has that nice corona. See it right there. Okay. Comfrey. Comfrey is another member of this family that has medicinal uses. There's a couple other members of this family that have medicinal properties. But Phacelia is your one required genus in Boraginaceae. They very clearly, like you can see in this picture, have that helicoid cyme. And just so you... Oh, okay, let's talk about the leaves first. The leaves are pretty variable. Sometimes they're like this, where they're so deeply divided as to appear compound. Other times, they're sort of more simple. But they always have those really kind of fluffy inflorescences like that. What makes them look especially fluffy in their inflorescence, I think especially from a distance, is the fact that they have very exerted stamens. That word exerted, it means sticking out. It's as opposed to like included within the corolla. No, in Phacelia, their stamens are exerted. Yeah. Cool. They come in many colors, the light purple, darker purple, kind of white. And as you can see from this picture too, we have a variety of leaf architectures. Again, here's that picture from earlier. And I think this might be my last slide. Yeah, one time I had parked our field rig to go to a site, a post-fire site, such as this one in this picture. As you can see, the background there is just very crispy. Well, this one time it's not where this picture was taken, but I parked the car. Our site was maybe 400 or so meters from where we parked. And when I parked, I got out of the car and I could feel something about this land. I'm like, where we parked, I had never been here before. It was all crispified, but I was like, I can feel something that I couldn't explain. And as we're walking towards our site, I could feel this stronger and stronger, and it's like kind of a sound maybe, or like a feeling in my body or my feet or something. Anyway, I really can't describe it. And as we approach, me and my field crew were all feeling this. We're all like, what? Is there some vibration in the earth or something? We get closer. It's basically a giant field of Phacelia with millions of pollinators. These bees were buzzing at all of these flowers. There were tens of thousands of plants, and there must have been millions of individuals pollinating these flowers. It was just such an experience that they were buzzing so much that we could all kind of hear it from a distance. Really cool. Anyway, long story short, pollinators love these things. Along with the bees that I could feel, there were also butterflies, moths, flies, everything you could imagine, loving these Phacelia flowers. So that's my story. I really like Phacelia. It might be my favorite genus, which is why I got it tattooed on my arm. You might have seen like my arm tattoo before, I don't know, in class. It's been a while. I could just show you on the camera, but this part right here is a member of the Boraginaceae, and they've got that helicoid cyme I always really loved, how they look kind of spiraled, just like the fiddleheads of ferns, which I also got tattooed on my arm. Kind of convergent evolution in form, if you will. Cool. Well, that's all I've got for you. I'll see you next time.